In 1973, in Hadar, Ethiopia, an intriguing fossil was found by paleoanthropologist Don Johanson.
I was surveying late one afternoon when we were out collecting some elephant teeth. And I looked down on the ground and found in a couple of pieces this knee joint.
At first, I thought it was just from a monkey, maybe a baboon, but
it went together in a way that didn't look like any monkey.
The knee joint was distinctive. It could be locked straight. This is characteristic of human knees, and it makes it possible for us to walk upright on two legs. No other living primate has a knee joint like this, which led Johanson to conclude that the fossil came from a creature that could walk a lot like us, perhaps an ancestor of modern humans. The knee dated from more than 3 million years ago. At the time of its discovery, it was one of the oldest fossils to show evidence for upright walking. The knee generated great interest in the scientific community, and the following year, Johanson and his team returned to Hadar to continue their research. Searching for fossils takes a trained eye and a lot of patience. One day, Johanson and his student, Tom Gray, were crossing a piece of ground they had walked many times before, when something caught their attention. Looking around, they saw parts of a leg bone, a piece of jaw, and a fragment of skull. A meticulous search revealed more and more fragments. Back in camp, assembling the pieces they had found, the team realized with elation that they had found most of an entire skeleton, older than any others known at that time. Characteristics such as the shape of the lower jaw and dental structure revealed a mix of ape and human-like traits, unlike anything found before. The skeleton was in hundreds of fragments, some minuscule. Each of them had to be meticulously cleaned and pieced together. The pelvis alone took hours to assemble. When they examined the knee, they saw it was a locking joint, like the one Johanson had found the year before. As the skeleton came together, they realized it was a very small adult female, just 3.5 feet tall. They now had a nearly complete picture of the creature and knew that she was an important piece in the puzzle of human evolution. That night, they celebrated and named the skeleton Lucy. Lucy's skull was incomplete, but they had enough pieces to conclude that her brain was quite small. Later expeditions yielded more skulls of Lucy's kind, and ultimately an almost complete skull. The delicate task of piecing all the fragments together fell to anatomist Bill Kimball.
Even already we can see that as we assemble larger pieces from smaller pieces, joining them together, we begin to get a fairly impressive picture of a species that has a very ape-like face with big protruding brow ridges, very ape-like.
Lucy's skull featured a receding forehead and prominent face. Her brain was roughly the size of a chimp's. Lucy showed that our ancestors walked upright long before their brains grew larger. Although recent fossil discoveries have revealed that earlier hominids were walking upright for at least 1 million years before Lucy was born, she remains a landmark fossil find more than 30 years after her discovery.